The broadcast is now starting. All attendees are in listen-only mode.
Good morning, good afternoon, wherever you are in the country. It's Mark from SolidCAM. We'll be doing our 30-minute free training session today. With me, as always, is Kevin Rankel. Hey, Kevin.
Hey, everyone. Thanks for coming.
So I thought today I would kind of look a little bit more at this one part. The part is done. If you tuned in last week, we basically started from scratch on this part, adding all the definitions, all the tool paths. But I did make a quick mention of how you could use the internal and external corner option inside the turning operation. So I was going to revisit that on this part. Specifically, I also mentioned how sometimes when you do a tool path, let's say like this one here, your geometry might be just a single line, or it might be a series of lines, but that first point is where you wanted to add that chamfer or that fillet, maybe break some edges there. But in this geometry, it is just a single point. So SolidCAM doesn't understand if that's an internal or an external. So I'm going to cover that as well in today's video. But let's go back into side one operation, where we did all of this turning. And we have this one corner right here. Now, if we take a look at that one corner, it's actually just going to come out as a sharp corner. We go into the turning simulation, just run through that real quick. And as we get closer and closer, you'll see that it actually is following the exact geometry. I have that set to the smooth option in your turning, in your roughing. So it actually just follows it per line, but as it gets there, it's just doing a little bit more lines, and then we'll see that it actually goes there, and it machines the sharp corner. So the movement of the tool is leaving that sharp corner there, and we probably want to break some edges on that because that probably is not where we want it to be. And obviously, this sharp corner here is not even possible. Our insert has a corner radius, so we definitely want to leave something there. So let's take a look at external and internal corners in that tool path. So open that guy up. Just as a review, my geometry is from the target profile, so exactly that geometry that we see on screen. And that's from the original design. So if you remember from the first couple of videos, I actually chose my solid, told it to do an envelope definition. It revolved the part around the center and gave me that external profile. So that is right from those solid faces, how it would intersect with the turn plane. That's generating those sharp edges. So the reason I bring that up is because oftentimes in milling and turning, but here more specifically with turning, if you wanted to change something about the profile, you would want to change the solid and then just resynchronize, recalculate, reparse the model, all of that. So that's what you could do to get your internal and external corners. You can go to the original design model, or you can even do it here in your feature manager and change those corners to fillets or chamfers. But let's say, for instance, here, we don't want to do that. We actually want to just make a change in the tool path, not changing the model because maybe you're not familiar with SolidWorks yourself, or you don't, you want to just do a quick change, recalculate, repost the code, and get going. There's the option in the technology section, break edges, where we can add the option for internal. Let me just get rid of this. Internal and external corners. So for the internal corner, let's add a fillet. Let's make it a little larger. We'll do something like 100 thou. And then for the external corner, let's add a chamfer. And the chamfer, I'll set it up as a 45-degree chamfer, also at 100 thou. A little bit of a preview. You can see that from our geometry, it's adding that chamfer there, and it's adding that little bit of fillet there. Let's add maybe something a little larger on that preview. Let's go with 250. Okay, so somewhat of a major change. You can see there that it's adding that fillet, and it's adding that chamfer there. So, save and calculate. A little bit of fillet there. Possibly lost my chamfer there. Let's see. Chamfer. Interesting. Okay. Not sure. It's doing it there, but it's not doing there. All right, let's turn that off, turn that back on. It's a good thing we're doing this live. There it is. Okay, so now you can see that it actually added that. So I guess you can't do both. So let's take a look at that in our profile, just to show that off again. So it does the same thing, does the layers. And then as soon as it gets there, you'll see that it starts to form the chamfer. Now this will count as a gouge, obviously. If we go into Solid Verify and run that again, let's just get that 2D representation there. It added the chamfer, and put this back to solid. But if we run the gouge check, it counts as a gouge. That is, again, because we changed it in the toolpath side of things, but not the design side of things. So our target definition still thinks that there should be a corner there. If I bring in the target definition, you can see that it's showing that there should have been a corner there. And then likewise, if we do fillet, recalculate, this time let's do a solid verify. There's our fillet there, but if we do the little gouge check, it'll show that there's excess material in that corner. So again, same thing. So per our target definition, that's not actually supposed to be there. So this is a quick way to get those internal and external corners, break some edges, without actually going back to the original model and making those changes. And you can find that a lot inside of our toolpaths, where you don't always have to go back to the original design model to make some sort of modification.
Mark, let's show them if we did want to make just a small modification to that, not the model, but the target envelope. We wanted to add that chamfer in there, per se.
Yes, okay. So what Kevin's referring to is not making a solid change where you would go to the design model and make the change to the solid, but if you went to the actual target envelope generated by SolidCAM. So right-click on CAM, which is our quote-unquote solid that we add to this assembly. Basically, this is where all the SolidCAM stuff is put. Everything under this window is not, usually we would say is not associative, but these envelopes are somewhat associative to their definitions. So the stock envelope is the envelope, the sketch that was generated for my stock definition, and the target envelope was generated by my target definition. I chose the solid, and it parsed the model and gave me that cross section. But let's say I'm looking to make the change like Kevin had suggested. I'll right-click, go to Edit Sketch, and while I'm inside the sketch, this is the official sketch that SolidCAM is looking at. So when I make the change here, this is going to affect everything on the SolidCAM side of things. Let's go in here, and we'll do let's add the chamfer. Let's say we're putting in that 100 thou chamfer. Let's just call it equal distance there, angle and distance, 100 thou chamfer. Let's put it over here and here. So the same chamfer we just did inside the toolpath itself. Click the green check mark to accept the change, exit out of the sketch, exit out of the solid. We'll just save that change to make sure that gets retained. Because remember, when you click save up here, you're saving everything on the SolidWorks side of things. As soon as we do that, yes, it's been changed. I'll just say yes. Target has a little symbol there indicating that it recognizes the change. And if we were to go and try and look at my, well, this was actually turned on solid. So let's actually reselect that geometry. But everything that was using that geometry would have been affected. It would have seen that change and not necessarily be associative, because this is not an issue of associativity. This is just an issue of we've changed what was being used at the time. So let's just go wireframe. And you can see that that target profile is what I was about to click on, like we normally would. I'd click from there back to, I guess it was here last time. And you can see that the model, the solid model, has not been changed, but it's using that new chain that we created. So just like that and like that. So that's another quick change you can make. It's not as quick as if you did it inside the operation, but every one of our toolpaths has a level of either associativity or a level of quick change. In this case, we could go back to the original target model. Now, this is not only useful for just chamfers and fillets, but this is useful for if you want to overcut, undercut, if you want to add One example, I think, I'm not sure if we have a KevCam video or a tips and trick video on it, but a lot of times when you're facing a part and it doesn't generate this front flat line, a purely vertical line, you might not have anything to actually click on for your facing operation. In that case, you can go into your target profile and add a vertical line, or you can even add a completely new sketch. Because when you come over here and you click on new geometry, I'm using the target profile, but that doesn't mean I can't just choose any sketch on screen. I can sketch anything I want, and as long as it doesn't interfere with the original target profile, it won't register as a gouge or anything like that. The only thing you can't choose in this window, or you can, but it's highly advisable not to, is any line that represents the stock. If there's a line here that is actually going to change per the stock definition, the updated stock definition, you can run into a whole loop of it's running off the stock, but then you've turned that stock, now the stock's not there. Like there's a whole logic loop that would happen there. So you want to make sure you only click on sketches that represent what it is you're trying to turn, nothing that's going to just change with the updated stock. Because we have seen that happen before. So that's basically how you can change the target profile either in the operation or in the target profile. Other than that, you would go back to the original solid model, make the change, resynchronize, recalculate, and then your profile would just change to match that. Now, let's say you had, let's update all these guys up to here. Let's say you wanted to add maybe just that chamfer, that fillet. You wanted to use that modification, but on the front end. Let's say this one edge right here being completely sharp. I want to do that internal edge, external edge. You can do what we just did, as per Kevin's suggestion, where you actually choose the geometry inside a sketch and add that chamfer. That's honestly probably a really easy way to do it. Really, it would make more sense, sort of thing. But if you want to do it in the operation, rather than choosing just that straight line, what I'm going to do is I'm going to go back into this turning tool path. Again, this is the one that we finished off with last week. And instead of choosing just that one line, I'm actually going to go new geometry. I'm going to choose this line, which represents this face, and then this line. So that forms a corner. If I'm doing just OD turning, this line is kind of useless. I would not usually choose that line if I'm just going to do some OD turning, because for the first thing, I've already faced it, so there's no material to actually be removed there. But if I need something that represents an external corner, I want to start from there, and then I'll go to Modify Geometry. And at the beginning, I'm not going to auto extend to the stock. What I'm going to do is I'm just going to highlight that 0 and then eyeball it. I'll say, let's cut short maybe about to here. So you can see that yellow line that represents my geometry has been trimmed to that point. And the reason I'm doing that is because when I go into my break edges, now for that being an external corner, I can add my chamfer. So let's say we add the chamfer of, I'm going to play it safe and just say maybe 50 thou. So something like that. So I've told it that that is now an external corner simply by choosing two chains or two lines that meet at that point. So that is understood to be an external corner. When I do my save and calculate, I now get a chamfer there. Somehow I messed this up already. Okay, so let's see. Angle 45. I think I have something like descending. Yeah, I'm not sure why I did that, but probably because we have a lot of stuff that we did just now that's updating the updated stock in a bad way. But you can see that it actually added that chamfer right there. So to just tell it that that is an external corner, I added the previous line there and then that line, and it understands it to be a external corner. I could do the same thing with the fillet. I could do the same thing with anything on here that I want to maybe add, maybe a little bit of a fillet or a chamfer on an internal corner. You can also do any kind of trimming or anything like that, anything that would make sense to modify the geometry as it is on screen. But again, you can always go back to the original solid model. You can go back to the target profile, and you can always make those changes. So does any of that make sense? Any questions on that? If you have any questions, you can always use the questions panel in your GoToMeeting. Okay, let's get out of here.
Hey, Mark, let's let's kind of cover the manual turning a little bit, because I feel like a lot of times where this may come in handy for some of our customers, but not a lot of people even know about it.
Sure. So manual turning is it's easy in concept, but actually executing it, I find is it's a lot of sketching. So it's maybe a little extra than normal. But what manual turning is right here. Manual turning has the same workflow, or at least close to the similar workflow. You're actually going to choose geometry. You're going to choose your tool, but in the technology section, that's pretty much it. There's nothing there for you to control here. Now you can tell it what's tool side to use for the drive geometry, but essentially what you're doing here is you are laying out the exact movements of the tool. It's called manual turning for a reason. You're actually manually controlling where that tool is going to go.
Yeah, so the nice thing with this is you guys can draw whatever crazy sketch that you would like, and it will follow that exact sketch pattern. And it's more to use for doing like custom tools where you just need to come in there and do like a double keyway or something like that, or a double O-ring groove or something along that lines. But it will follow whatever direction or whatever you sketch on there to a T. So, you know, maybe that first initial one you want to do a little bit of a wave. That wave gets bigger and bigger and bigger. It's like, you know, it's hard to explain, but you can create your own custom, almost turning cycle based off of the sketch itself.
Yes, yes. I think when this was covered in the CAD/CAM night class, you had the example of maybe turning like a surface hardened material. Like the first couple of cuts had a shallow cut, and then as you get closer and closer to the center, because now it's no longer strength hardened, you can take deeper cuts. And the way to get that done was with the manual turning, because what you do is you literally sketch out each pass using SolidWorks sketching. And all of that, the tool that you're using, follows whatever you've put as your reference point. So in this case, if I tell it I'm using this grooving tool and I'm defining the grooving tool on that point there, that's the point on this tool that's going to follow my chain. So good example of what that means is the mistake I'm about to make. I'm actually going to choose this tool, and with my geometry, let's choose, now it's under Mac 2 for whatever reason, so I guess it's not, I don't know why that's over there, but let's choose some geometry under Mac 1. Yeah, Mac 1 looks okay. I'm not sure why that's there. And let's choose just this exact chain that we had before, maybe just up until this point. So the tool is the same. You would define the tool in the exact same way you normally would, and it's going to follow that chain as it would. But manual turning is not going to account for the shape of the tool. It's not going to look at the updated stock to make sure that I'm not gouging it. It's actually just going to follow all of that exactly. So if we do a save and calculate on this, and then let's just do a quick host CAD from the side view. So here's the tool. That's the corner that follows that chain. So far, we're okay. But then as soon as we get down there, that point is still riding along that chain, but it's gouging. If we continue along here, it's still that same point that follows along, but it's not accounting for the shape of the tool. So this, I think another example that was shown in the CAD/CAM night class was we had, like Kevin said, a double O-ring groove. You've got a custom tool with multiple inserts on it. How would you actually use that inside SolidCAM with the regular toolpath? You can't really do that. With the manual turning, you can, only because you are accounting for the shape of your tool. So if you've got two O-ring grooves that you have to machine in one turn, and you've got the tool that can do both of them, well, really you're just going to define one of those points on that insert or on that tool, and then you're going to sketch geometry that follows a pattern that you create. So you actually machine it per your own trajectory, your own tool path. So that's basically what this is. If you take a look at it again, all it's going to do is follow that exact chain, but to a T. That reference point is in constant contact with that chain, and it gouges on the way over. But it's really useful for really unique tools, really specific movements of the tool, and that's why it's included as one of the toolpaths.
And is that the toolpath that you used when we were looking at doing that broaching? for one specific customer, gear hobbing, or what we're looking at?
Oh, you mean that spline?
Yep.
Situation. No, actually, no. With that, what I did was I defined a well, I don't think that video has been released yet, or we even showed it to anybody. But what I did with that one was I actually created just a standard toolbox cycle, which I think you covered last week in your KevCam night class. The toolbox cycles, and I used broaching. Actually, I can even bring up that file. Why not?
Yeah, because it was one that you drew, so I think we should be safe.
I think I still have it somewhere. Let's see, recent CAM parts. I should still have it somewhere. Let me look off screen. There was an application that was asked if we can do, I guess, like, was it like splines or something like that, but with actually, I don't even remember what the application was.
Creating a spline using a lathe insert. So basically like a cut-off square insert. And while you're trying to find that, I've got a question from Brian. What is the difference between a sketch in CAM and a sketch outside at the assembly level? So outside, so here's the difference, or at least the way I like to put it is if you do a sketch in the assembly level, so it would actually populate down at the bottom where it says chord sys, yep, down there. What that would do is if our model was to change, that sketch would still stay there. So if we're doing a family of parts and you still want to keep those sketches there, then that sketch would still stay there. If you did a sketch inside of the design model area or the CAM model, then when we go to do our change model reference and change that out, that sketch is gone.
Well, the sketch is gone only in design model, right? CAM, it stays?
Oh, I'm sorry. Yes, in CAM it would stay. Sorry.
Yeah. I think the difference would be, it's exactly what you're saying. It's a matter of associativity. It's design model versus everywhere else. So you'll lose that sketch if you do it inside of design model, because that's going to be associative to the current design model. So like Kevin said, if you do a change model reference, the difference between CAM and outside here, the sketch itself, there's really no difference. But I have found that if you try and do a sketch on a assembly level, you don't have as much access to some certain geometries that you do when you go inside of a part file. Things like, what's it called? Well, first, I mean, if I go to sketch here, I think this is a perfect example. I don't really get the ability to do offsets. You won't really sometimes be able to do convert entities, because on the assembly level, there's no specific solid that you're looking at. So it's kind of more of a SolidWorks question. When do you do sketching in an assembly level versus when you do it on a part level? That's really the difference. This is a part level sketch and this is an assembly level sketch. But I've found that oftentimes it's easier to do it in the CAM solid, because then you're inside of a solid. So you get the full functionality of doing sketching. Whereas if you do it on the, let's say we're here on the assembly level, sometimes when you do sketch and you try and choose a plane, you're not going to get certain, I mean, now that I'm inside the sketch, you can do offset and trim and all that, but there's certain things that you just don't have access to because you're on the assembly level or you're in the part level. To me, it's more of a SolidWorks question. So I'm not sure what fully the difference would be between a part level and an assembly level, but that's what it is basically. It goes down to that main difference in sketching. Now, in terms of the thing that what Kevin was asking about, let's do a quick deep dive into Mark's little level of files here. We've got this one here. Perfect. Okay, so let's go down to part files, SolidCAM files, broaching, spline tests. No, that's not it. Where is it? Interesting. Okay, no, that's not it. I really hope I didn't delete it. Well, basically, I'm not going to try looking forward for the next 5 minutes. Using a turning insert, we were still able to do broaching, but with the toolbox cycle. And then what I kind of done was, for the broaching tool, I defined it as just a simple square. and then I used an STL holder to represent how it would actually be held in the how the insert would be held in the turret. But then using the toolbox cycle, I kind of got it to go in a from the looks of the preview, it looks exactly like it would look on the machine, but the movement of the tool is not exactly in the exact Z direction. It's kind of, I had it mounted in the X positive direction, and it looked like it was using a turning tool. What we could probably do is, if that is an application that's applicable to other people, I can either find that file for whatever reason, or I can just recreate it. We can do it in a future SolidCAM Live class if you find that you guys are doing a lot of broaching. But every toolpath inside SolidCAM has the ability to do the transform command. So if you're doing splines on the outside of a turned part, then use the toolbox cycle and then use the transform fourth axis command to do all the splines. And you can just go around the part as many times with as many angular increments as you need. But it'd be easier to show it than to talk about it, but I can't find the file.
To be continued for tomorrow.
Oh. To be continued, yes, yes. I love it when cool stuff comes up, but I forgot where I put it. So now we don't have anything.
Or when I throw it yeah for a curveball, and we weren't going to even talk about that today.
Yeah. Stump the chump is like we used like to refer to it.
Yeah.
But if any of you have any parts, topics, questions, or anything like that you'd like us to show as evidence today, we need it. So if you have anything that you'd like to see in the SolidCAM Live, Kevin's going to put my email in the chat section, and you can send me your parts, questions, topics, comments. If you think that you don't like it when we don't have stuff, you can comment on that as well. You can use the email that Kevin's going to put in the chat section, or it's actually already there. In addition to that,
one last thing, it's really quick that we could show everybody.
Sure.
Are you running SP2?
Yes.
Okay, go ahead and open up.
Double check that I have that loaded. Yes. So if you guys weren't aware, SolidCAM 2020 SP2 is available.
Go ahead and open up any CAM file.
Milling or turning?
Let's do milling.
Okay. We'll open up our old friend here, HSM.
In the new SolidCAM 2020 SP2, in the beta simulator, you now have a full tool measurement that is identical to what SolidWorks does. So Mark, go ahead and just click on a straight line on that part real quick for me. So you'll see at the bottom right-hand side, it shows up length 7 inches. So now go ahead and open up the beta simulator. Now, if Mark clicks on any one of those edges, he'll get a measurement in that same location. So you can see, not the face, do the edge.
Should it be snapping?
Yeah, just click on it. Should be able to go through it. Go ahead and play it through. Well, go ahead and play it through. The real cool thing about this is, okay, go ahead and pause it right now, Mark. If Mark wanted to get a measurement on this, he could just click on the line and it would give him the actual measurement itself. And kind of where this came handy is one of our customers is running shop floor editor on his computers down on the shop floor, but he needs a way to get measurements off of the solid model as well as the finished model. So now you have that option in there to get a measurement off of all this. So you can see like right there, a length of 7 inches. That kind of makes sense for everyone, what I'm saying there? And as you play it through, Mark can actually click on the model itself and pause it and get a measurement. And it's the same way if you were in SolidWorks where you got to hit the control key if you want to measure like a distance, or if you wanted to measure angles. You may want to turn off your toolpath is probably why it's a little bit tougher for you to click. So click there. And it's going to make a liar out of me.
Yep. Today is not a good day for SolidCAM Live. I have seen this function, and it is exactly like Kevin suggested. I think there was a KevCam. You maybe already showed this. Maybe
no,
something wrong with this part.
Yeah, this just came out in the latest SP2. In here, can I have keyboard and mouse control? Try something real quick.
Okay, go ahead.
Well, I just tried it on mine. Target. Well, apparently something is, because the weird thing is I'm over here, and it's, so if I click that, it's getting that line there. So it's like the graphic. We may just have a bad install on yours, Mark.
It could be. I have had a few things last week that made it seem kind of odd, but that's probably just my install. What Kevin's suggesting is that it's probably just my setup, but on my individual system. But in reality, this would work to measure the way that we're basically saying. It has a similar functionality as to what you would see inside SolidWorks. You can choose an edge, a face. Using the control key, you can actually do relationships between things like angles and distances and that sort of thing.
I got an angle line there, and if I come over here and somehow get this, so it'll give us a distance in there for us. If you guys want, let me just see what I have pulled up on mine. No, I don't even have anything pulled up. Maybe tomorrow we'll show you more on this one. It actually works quite well. Like I said, you can get a measurement halfway through machining. So if you're coming in here and looking, it's like, ooh, that looks a little bit off, you can actually get a full measurement right off of that live. So it gives you real in-time machining data for you as well. And like I said, if you guys are using this for the shop floor, for those of you guys that don't know what shop floor is it's a running SolidCAM as a standalone. So there's no SolidWorks that is needed. And you can go down, and a lot of guys are using this on the shop floor, where you can go down and make modifications to the geometry, feeds and speeds, step downs, all that. But now you will also have the ability to get measurements off there. So if you know, the setup guy down there, it just wants to double check the stock measurement, then he can go in there and measure off of that stock too. So yeah, Brian, Brian asked if there's a selection filter that's turned on, and I think it's just a graphical, because if I'm over here, you can kind of see, I don't know, I can't even get it to do it.
Well, it's like you said, we can cover this tomorrow when we have probably a better part. Adjust my settings, or even we can look at your screen because you got it to work. So it's every time you have an issue like this, or even any other type of issue, it could easily be a system issue. So what you want to do is always call us at the main tech line, and we can take a look at it for you, because there might be stuff that you are absolutely doing right, but it could just be something that you're not aware of that we would need to check to check. There's a lot of different computer-related things that that we could check for you, or even just improve for you as well. If you find that you are, if there's a lag in calculation, or it's just not representing correctly in Solid Verify, give us a call anyway. There's something we can take a look at to optimize your system, or even just correct something as well. So there's always something that we might be aware of that just as a general user you're not aware of. So always give us a call at the main tech line. And that would be extension 2 on the main North American line. I'm not sure if we get anyone outside of North America here, but but that being said, we'll cover that tomorrow or whenever we can. For today, we'll end it soon. So I mentioned emails in the chat section. Send me your parts, questions, topics, comments, whatever you'd like us to know, whatever you'd like to see in the SolidCAM Live. If you know anybody that can benefit from SolidCAM, let them know about SolidCAM. Give us their contact info. If they go into a demo, you get that $100 gift card. If it goes to sale, you get a finder's fee. You get a certain percentage of that sale. I believe it's 20% of the final sale. So depending on what we sell them, that could be a huge chunk of money just for helping us sell SolidCAM. Just get people in the know about SolidCAM. But for today, we'll call it a day. We'll end this here. We're doing this every day until the end of June at 2 p.m. Eastern time. But for now, stay safe, keep your family safe. Talk to you guys tomorrow.
All right, see you guys.